Alrighty, so in this video, we're going to go over the central limit theorem for sample means. So what is the theorem? It states that if our sample size n is greater than or equal to 30, then the sampling distribution of sample means is approximately normal with the following parameters. Okay, so what this means is that, so what is a sampling distribution of sample means? It's if we have a bunch of different samples. We take a bunch of different samples and we calculate the mean from each of those samples. The collection of all of those sample means becomes approximately normal as long as our sample size is big enough. And as you guys know, being normal is important because if we're normal, we're able to find probabilities. Well, to find a probability, we need to know the mean and the standard deviation. And so the mean of the sampling distribution, it turns out that it's the same thing as your population mean. However, the standard deviation that you use for this sampling distribution, which we refer to as, let's make this big. We refer to this as the standard error. And it turns out that the standard error is we take the population standard deviation, and we divide that, I don't know why I'm writing in capital letters, but we divide that by our sample size. Okay, so that's it. So if our sample size is bigger than 30, then we can say that the sampling distribution is normal. All right, let's get through one example here. Suppose professor salaries at a particular college follow an unknown distribution with the mean of 75,450, standard deviation of 12K. What is the probability that in a sample of 40 randomly selected professors, the mean salary is no more than $79,000? Okay, so here's what's important about the central limit theorem. Because the distribution is unknown, if we didn't have the central limit theorem, we wouldn't be able to find this probability. But because our sample size is 40, which is greater than or equal to 30, we're able to apply the central limit theorem. So we need to figure out the probability that our sample mean salary is no more than $79,000. No more means less than or equal to, but less than is fine. We're going to do this. X bar is less than 79,000. That's what it means to be no more than 79,000. Okay. So to solve this probability, we're going to use our calculator. We're going to use Normalcdf. And Normalcdf, hopefully you're familiar with it. It needs four things. It needs a lower bound. So if we're talking about being less than 79,000, our lower bound is a negative infinity, which we indicate by writing a negative 1e99. The upper bound is going to be that 79,000. The mean, well, this is where for the mean and the standard deviation, we're going to have to apply the central limit theorem. So the central limit theorem says the mean of this distribution, of this sampling distribution, that's what the X bar represents. The mean of the sample means, which is weird, is equal to the same thing as the population mean. Well, the mean for all the professors at this college is 75,450. Okay. So in Normalcdf, we're going to put in 75,450 for our mean. The standard deviation. Well, you can't just use the standard deviation that's given to us because it's a sampling distribution. What we have to do is we have to scale that standard deviation. What we do is, according to the central limit theorem, remember, you take your population standard deviation, you divide it by the square root of your sample size. So we're going to take $12,000. That's our population standard deviation, and we're going to divide it by the square root of how many professors we have in our sample. We have 40 professors, so we're going to take that square root. And as I said in another video, because we're going to round our answer to 2 decimal places, what I highly recommend is that go ahead and use 3 decimal places for all of your work. And then at the very end, we're going to round it down to 2. So what we're going to do is we're going to go ahead and calculate this standard error to 3 decimal places. Okay. So let's see, we're going to take 12,000, divide that by the square root of 40. All right, 1897.367. 1897.367. And this is what we're going to feed into the calculator for the standard deviation. We're not going to give it the 12,000. We have to give it the standard error since we're working with a sampling distribution. Okay. So here we go. We're going to feed everything into Normalcdf. Second vars. Let's see, number 2 for Normalcdf. Here we go. The lower bound was -1 E99. The upper bound was 79,000. Okay. The mean, I do not remember. It was 75,450. And the standard error, or the standard deviation we're going to use here, is the 1897.367. All right, we go to paste. Hit enter. And there we go. We've got a probability, 0.969. So this probability is around 0.969. If we want 2 decimal places, our answer would be 97%, 0.97. So there is a 97% chance that if we grab a random sample of 40 professors, that the average salary between all of those 40 professors is no more than $79,000. All right. So that is it, folks. That is your central limit theorem for sample means. Hope this helps you out. I will see you all in the next video.